Alright, so now we're just going to talk about number 20 and 21, which is rationalizing a denominator. So first, let's discuss how to rationalize, let's say, 1 over the square root of 2. So, and before we do that, let me tell you why we rationalize. So the reason why we rationalize denominators, or that's just a fancy word for saying having no square roots in a denominator, the reason is because mathematicians have just decided to not have any square roots on the bottom of a fraction. So you can think of this as just merely a convention, right? We've decided that we don't want square roots on the bottom, so every time we have a square root on the bottom, we decide to make it so that we put it on the top. Yeah, so far does that make sense?
So did we forget something?
Alright, so now the way we do it is in this case, we multiply the top and bottom by the square root that we have on the bottom. And in this case, it's the square root of 2. And the reason why we can do this is because the square root of 2 over the square root of 2 is just 1. So we're not changing the value of the fraction, right? And so the top becomes square root of 2 times 1, which is square root of 2. And the bottom, we actually get rid of the square root because square root of 2 times the square root of 2 is just 2. So it becomes square root of 2 over 2. So 1 over the square root of 2 is the same thing as the square root of 2 over 2, just a rationalized version. Now if you plug this into your calculator, you should get the same thing as this right here. So far, do you have any questions on that? Alright, now these could be a little bit more complicated where on the bottom we don't only have a square root, but we have some sort of constant as well. So in this case, for example, number 20. Number 20 says we have 3 over 5 minus 2 root 3. So similar idea here, but what we do is now we multiply the top and bottom by 5 plus 2 root 3. So we change the sign of this, and we multiply top and bottom by that. And again, we're not changing the fraction, right? That's the whole goal, because we can't really, if we change the fraction, then that's illegal, right? We can't quite do that. And we're not changing it because this thing over this thing is just 1 again, right? So 1 times anything is the same. Now we multiply it out. So the top we use FOIL. 3 times 5 is 15. 3 times 2 root 3 is 6 root 3. And then the bottom, let's see, we get 5 times 5 as our first term. That's 25. 5 times 2 root 3 is our next term, so plus 10 root 3. Negative 2 root 3 times 5, so minus 10 root 3. And then lastly, we have negative 2 root 3 times 2 root 3. So that's, let's see, minus 4 times root 3 squared, so minus 4 times 3. So that's just minus 12, so I'm going to write it as minus 12. And then notice that, let's think about what we were trying to do initially. We're trying to get rid of the square root on the bottom, right? And in this case we did, because the 10 root 3 cancels with the 10 root 3. So we're no longer left with any square root on the bottom. So the answer is 15 plus 6 root 3. And then we can simplify the bottom. How can we simplify the bottom? Right, so this becomes 13, and it looks like that's the final answer. 15 plus 6 root 3 over 13. No more denominator square root. Any questions? Alright, perfect.